So to kill a black hole, we have to send it back in time?
Yeah, we're fixing the future by ruining the past.
That's right, folks. We're back.
Ruining everything, one cosmic object at a time.
Welcome to Dead Planet Society from New Scientist. It's season 2, and we're doing some gleeful cosmic destruction once again. I'm Chelsea Whyte.
And I'm Leah Crane, and we're so happy to be back to tinkering with the universe.
We are. If you missed season 1...
First of all, how very dare you?
Yes. And second of all, you can listen to all of it after you finish up here. But for the uninitiated, this is a podcast where we imagine what it might be like if we were given cosmic powers to rearrange the universe. And today, we're going after the universe's most powerful supervillains, black holes.
Destroying a black hole is going to be tough because anything you throw at them has a frustrating tendency to just fall in and make them bigger and more powerful.
Yeah, so we did have to get pretty creative here. Should we aim for the biggest ones out there, or just focus our attack on the itty-bitty black holes?
Well, the biggest ones would be more satisfying, but tough to take down. Smaller black holes might be easier to wreck, but they can also be more dangerous. So we're gonna have to bring out our cosmic tool belt for this one, and add a tool or two, including a cosmic Zamboni.
So we called up Allison Kirkpatrick, a black hole astronomer at the University of Kansas, to help us dream up the best way to take one of these suckers down. Or perhaps all of them. So let's start with the big question. Is it even possible to destroy a black hole? I mean, it's like the biggest, most powerful thing in the universe, and I want to go after it.
We're beating up the biggest guy.
Yeah.
to display our dominance.
So is it possible? Well, a black hole can theoretically destroy itself, maybe. So it can radiate away its mass through Hawking radiation, possibly.
Say more about that. So what is Hawking radiation, first of all?
Okay, so Hawking radiation is, it has to do with quantum field theory, and black holes are basically the domain of general relativity, right? It was, the general relativity equations that lead to the idea that you can have a singularity of infinite density. And back when those equations were written, we didn't know a whole lot about quantum mechanics, so we didn't have to deal with those implications yet. But it was Stephen Hawking who basically looked at like quantum field theory and said that there is this unique property of quantum field theory and black holes, in that the way that black holes will bend the field will cause the creation of particles and antiparticles. This is okay because particles and antiparticles collide and annihilate each other. Okay, nothing is violated. But let's say that doesn't happen. Let's say that your antiparticle happens to fall into the black hole and the particle doesn't, and it accelerates away. And so all of a sudden you've just created some mass. And so that we don't violate properties of the universe, the black hole needs to also give up some of its mass.
So the general gist is that because of quantum mechanics, black holes are leaking a little bit.
Yes.
Possibly.
Yes.
You think.
Right. And so black holes should actually radiate at a temperature that is inversely proportional to their mass. But it's like, it's such weak radiation that it can't be observed. The radiation should be a lot stronger once you have a very, very small black hole. And so like for example, micro black holes, which is what we're going to talk about, when they finally like give their little burst of radiation, they'll evaporate completely. You should be able to detect that. And so if you remember, there was like a big panic, years ago, that the Large Hadron Collider was going to create these micro black holes. It would be really awesome if they did. We would love that. And then they would radiate away so quickly, but so they might have already done it and radiated away and detected them, but it's not a signature that's unique to the black hole, so we can't say it for sure. It was a micro black hole.
Cool.
So the only way black holes naturally might be defeatable is by waiting possibly forever. for them to get really tiny.
To get really tiny, right? Because even if you like starve them and you cut off their fuel supply, which happens to a lot of black holes, there's just no natural mechanism for them to get rid of their mass.
I think we're going to have to turn to an unnatural mechanism,
Yeah.
as we often do.
Well, we delight in here.
So it seems sort of obvious, but throwing anything at a black hole isn't going to do anything to it, right? Even if we threw, 100 million nukes into a black hole. I'm sorry, I always go with nukes, but if we throw,
Can we bomb it?
infinite
No.
TNT into a black hole,
Yeah, you'll make that
probably
black
not
hole
gonna do
bigger.
anything.
Yeah, it's going to make your black hole bigger.
It's like the worst
yeah.
supervillain.
It is. To do anything to a black hole, if you could theoretically, let's say you could make a bomb that explodes faster than the speed of light, then you might be able to start blowing off some of the matter.
Oh, that's cool. This I like.
Yeah.
I mean, we can't, but
Well, sure, but in our minds.
Right. So the current problem with a black hole is that the escape velocity, so like on Earth, if you want to leave the surface of the Earth, your escape velocity needs to be 11 kilometers per second. And then you will leave the surface of the Earth. The problem with black holes is that the escape velocity is larger than the speed of light. So if you could make something that travels faster than the speed of light, then maybe you could get out of there and maybe you could grab some stuff and take it with you.
Right, and then we could break it into pieces that were much smaller, and then the Hawking radiation could do the rest of the job.
Could do the rest, sure.
But in general, black holes just feel like infuriatingly sturdy to me. Like
they are.
Yeah. So I'm wondering if like approaching it from the opposite of a black hole, like there's a thing called a white hole, right? There's an idea that there may be a thing called a white hole.
Yeah.
There's a somewhat controversial idea that a white hole which spews instead of swallowing.
Right. So instead of like nothing can escape, nothing can enter, but it's spewing stuff out. Like if we pitted them against each other, if we like threw a white hole into a black hole,
they should annihilate.
They should, annihilate. Right?
Yeah. Yeah.
Like antimatter.
Right.
Would it take time?
No.
It would just be immediate.
Yeah.
Okay, so then we just need like a t-shirt gun full of white holes to just shoot across the universe. So if we did get a white hole and we were able to throw it at a black hole, maybe with our t-shirt gun, would it be spectacular? Like what would it look like?
Right. And so I think the idea behind this is that it would cease to exist, but all of the mass would be converted into energy because you cannot destroy mass. Right. So the total amount of mass and energy in the universe always has to be conserved, no matter how many white holes and black holes you have. And so rather than having a massive object, you would have a burst of energy.
Like a big fireworks show?
Again, I don't think you'd be able to see it. It would probably come off in gamma radiation because that's what particles give off when they interact. So if you were too close, you'd get cancer.
Well, okay. Yeah.
If you were too close, you'd get immediately dead, probably. If you were too close, you'd have already fallen in.
These are the hazards of being a dead planeteer. I don't know. That's, that's going to happen.
You're either going to fall into the black hole, you're going to get absolutely ruined by all the stuff coming out of the white hole.
Okay,
if you're
fair
too
enough.
close, you're long gone. So that brings me back to my other question about antimatter. But if you threw antimatter in, antimatter still has positive mass.
Yeah, antimatter is just matter. Well, it's not just matter, but it's matter with like opposite properties. It still has mass. We could have like a whole Earth made of antimatter. You could be made of antimatter. You're not. But in a parallel universe, you could be. We could have had an antimatter dominated universe. So when we say antimatter, it kind of gives off the wrong idea because these are like normal particles. They just spin a different way.
Right. So they're not They're going to fall into the black hole, maybe annihilate when they're in there, but that's not going to actually cause anything visible or any notable effect.
No.
Now we have a special offer for Dead Planet Society listeners. You can get a 10-week digital subscription for $10 or £10, which includes unlimited access to our website and app. To learn more, go to newscientist.com/DPS offer.
And if you enjoy our podcast, you might also enjoy my free monthly space newsletter at New Scientist, Launchpad. Check it out at newscientist.com/launchpad.
So here's a question. If we throw enough stuff in a black hole, if we keep going,
Yeah.
would it eat everything? Like, could you make a black hole so big that it swallows up everything in the whole universe? Is there a limit?
Sure.
Like, if we can't break it apart, can we make it the only thing left?
Yes.
Okay,
Yes.
great.
Like easily.
Yeah, sure. Okay, but the problem with that is I think you're actually going to need to put in more stuff than the universe actually has in it right now. So you're going to need to
Oh.
get some of the multiverses and throw some of the multiverses in there as
Why?
well. Right. So this is what led to our understanding of what the universe is going to do long after we're dead, up until 1999, 2000. There are competing models for what the universe was going to do. One of them was going to be the big crunch, right? Where the universe was going to collapse in on itself. And now we know that that's not going to happen. The universe is going to expand forever. The reason we know that's not going to happen is because there's not enough gravity in the universe to overcome dark energy pushing the universe apart. So you would need to increase the gravity in the universe to be able to pull the outer reaches into your black hole. So you'd need a lot more mass than we've got. How much more mass? I don't know. Maybe triple?
Or we could just attach thrusters to all the stuff at the outer reaches and
Push
throw
it
them
in?
into the black hole.
Yes, and push them in. Yeah, you could do that.
Yeah. We could do our cosmic street sweeper. We could Zamboni them in.
Oh, I do want a cosmic Zamboni. That sounds incredible.
One question we were wondering, which I guess is sort of the same as just doing a white hole, but could we attach the black hole via wormhole to some other point in space so that it just leaks?
So first of all, wormholes need to be real.
Well,
and
yeah.
that's not clear.
That's a
That's
if you believe with your heart hard enough, they are.
But also, wormholes are black holes, right? It's black holes connected to other parts through a wormhole.
I guess I'm wondering if we could have a black hole, white hole connection.
Yeah, that's the idea. That is the idea, is that you, that's the fake idea. That's not the real idea. The real idea behind a white hole is that it is a natural consequence of the general relativity equations, and that it exists within a black hole's past, because like time doesn't flow in one direction. And so if you follow a black hole into the past, you would find a white hole. So basically a white hole is a mathematical concept which doesn't need to exist, right? There's lots of things that are mathematical concepts, like imaginary numbers, that don't actually exist in reality.
This is devastating, by the way.
I know. I'm so sorry. But then the sci-fi idea is that black holes and white holes are linked together through wormholes. But I believe if you want to lump in general relativity and your sci-fi idea, if you're going to travel through a black hole to a wormhole to a white hole, you're going to need to go into the past.
Oh, so to kill a black hole, we have to send it back in time?
Yeah. Well, then you'd stop it from getting bigger.
That's incredible. I love this.
Yeah.
Nice.
We're fixing the future by ruining the past.
That's right.
Yeah, what happens if we do that? In that part of space-time?
Paradoxes.
What I'm saying is, if we push a black hole back in time, and there, in that time, wherever millions of billions of years we push it back to, there was something else there. Does everything there just get like sucked into it or exploded or both?
Yeah, it won't affect the present very much. But yeah, you'll ruin someone's day in the past.
Well, yeah. But wait a minute. Won't it affect the future or the present? Because
No.
if we got rid of the black hole at the center of our galaxy, wouldn't there be some
Black hole at the center of our galaxy is not doing anything. It's
okay.
very small. It's about
Let's slander the black hole.
yeah. I'm gonna. I don't like it. I'll talk crap about it all day. That black hole personally hurt me and my family.
That's how I feel
Down.
about the moon.
Okay, Allison, this is a revenge heist now.
No, that black hole is weak. It is about 1/10,000th of the mass of our galaxy. And so supermassive black holes in galaxies are really small. We are not orbiting around them in the same way that we are orbiting around our sun. So they're just kind of there. They're just kind of like these black holes were wandering around one day in the early universe and they just fell into a galaxy. The galaxy doesn't care if it's there or not.
Then let's get rid of all of them.
Yeah, we can exactly. We can send them all to the
into the
past. We don't need them. They need us. We don't need them.
The thing is, though, if you send them into the past, they're gonna come back to
they have a chance to get bigger.
Yeah, like suddenly we change the future in a pretty rough way.
I had an idea, and I think it's maybe very stupid. However,
Okay,
the thing that makes a black hole is its density, right? It's not necessarily its mass. Mass is everywhere. It's that mass is so concentrated.
that's right.
So I wonder if we could just stretch it out over a larger volume such that it stops being a black hole and starts just being a dense but regular object.
If quantum mechanics is correct, and it does have a size, then yes, you could stretch out that size. Okay, now, if GR is correct, no, it's not going to happen. Because in general relativity, what it's saying is that it's not, you can't think of it as an object. It's not an object. It's just the curving of space-time. So it's just like, you're driving along a road and then your road goes off a cliff. And so you are curving space-time basically down to an infinite point. And so you need to be able to travel to infinity to like shake out that sheet and stretch it out again.
Right. It's like trying to fix a hole in your shirt with an iron.
Yeah.
You just can't iron that out. But if quantum is right, what I'm thinking is sort of drawing and quartering the black hole. What I'm thinking of is putting a bigger black hole on either side of it and see if we could just stretch
In four
it
corners,
out
yeah.
tidally.
Could we?
This might be my best idea ever. I know I
It
just said it
is.
was incredibly stupid.
This wasn't what I was thinking. I was going back to the nuclear bombs and getting us a ship that travels faster than the speed of light and getting down to the infinite point source, or not the infinite, the tiny point source, and then throwing all the nuclear bombs at it and then traveling out of there.
Expanding it. Yeah.
Or like riding the wave out of there.
Sure. If we're going to have an infinitely fast
Surf the
spaceship,
shockwave.
yeah, we'll have some, so shield on it.
Yeah, I want to surf that black hole destruction shockwave all the way to the edge of the universe. I know there's not an edge. Let's not get there. But the other way, if general relativity is right, correct me if I'm wrong, but it's sort of like the biggest pothole in the road, right? Like it's just like a deep well.
Yes.
And I'm wondering if there's a way to like yank that well up. Or like put something like that can magnet it back to flat. Or if I don't think that's possible, but is there a way?
I think the magnet idea is interesting because we know that they have magnetic fields around them if they have material around them. So I kind of like this, maybe a giant magnet. And it's possible that the material that falls into the black hole actually does retain some information. So again, GR says that everything that falls into a black hole loses all conception of itself. Like it doesn't remember who it is or what it is. But we don't really know if that's true. There's some hints that might not be true. And so maybe things that fall into it maintain their magnetic properties, and then you can put a giant magnet and suck
Yeah,
them
like
out.
one of those big bar magnets, Wile E.
Yeah,
Coyote style.
Just like
Yeah.
iron filings, you just suck them out.
I feel like this is possible, and we're going to do it.
Okay. Sounds great.
And you know what? There's a lot of black holes, so we've got a lot of practice material.
Yeah. If one goes wrong, we'll do it another way.
Yeah, no, I'm gonna throw something, throw a wrench into your plans here. The black holes that we have a lot of are stellar mass black holes, and in fact, there's just like a ton around us in our solar neighborhood, and so those would be the ones you want to play around with. The problem is, so I'm currently live in the state of Kansas. If you take a stellar mass black hole and you place it in Kansas City, then if I am over in Colorado, it's actually going to rip me apart by tidal forces.
So just like
So-
a couple 100 miles away.
Yeah, like a few hundred miles. So you can only get within a few hundred miles, which I don't think is going to be close enough to get your magnet to work.
If we have a cosmic magnet, it will be the strongest thing that's ever been built.
This is true. If we are making a magnet strong enough to magnet out stuff that's in a black hole, I feel like we could probably find something that's a little stronger than carbon fiber, or we can find something real strong.
Yeah, just amp it up a little bit.
Okay.
Listen, we have magic powers, and we're going to do this.
I feel like, given all of the other things that we've created, real good material cohesion, that's a piece of cake.
But wait, so does that mean that spaghettification, the thing that happens, like if you jump into a black hole, your fingers and toes like end up noodly,
Yeah.
and you stretch out into ribbons? That I always imagined happening after I crossed the event horizon, but for a stellar
for a
mass
small
black hole, it
one.
could happen outside the event horizon.
Mm-hmm.
Oh, I want to send some stuff here by some stellar mass black holes and do some tests here. That sounds fun.
Okay, just don't get too close.
Yeah, I just want to like from
Just
afar.
chuck things.
Okay.
Yeah, I want to see what spaghettification looks like. Can we have video, please?
And it's not littering because it never comes out.
Right.
No,
All right.
no. This is not true. No. Because you're going to be ripped apart before you are close to the point of no return. So you're just creating more pieces of yourself.
Okay.
But they'll get into an accretion disk and eventually fall in.
Yeah,
right?
an accretion disk of people, I guess, is what you want to make.
5
I
seconds
was
ago, we were talking
suggesting-
about throwing objects.
Yeah, I was suggesting items, but you know.
Okay.
Just the gory. I'm just imagining it. And
But if you did have an
nightmare.
accretion disk of people, then as they fall in, now you have all this iron. And so now we can apply our magnet and maybe pull them back out.
Okay, incredible. Well, maybe worth it.
them.
We'll pull their blood back out.
Their stuff. All the stuff that made them.
Oh God, we'll pull their blood back out is one of the most horrifying sentences I've ever heard. I love it. I think we might be good on destroying a black hole.
Okay.
Yeah, we've come up with quite a few ways to do it. Thank you. They seem like
Nightmare.
they will not be successful, but I'm okay with that.
As long as
So-
you're not in the accretion disk of people.
Yeah, that I'm going to avoid.
I'm getting
Although, to be honest, what a way to go.
Thank you for joining us for Dead Planet Society. We're so excited to be back for a second season. And if you do want to catch up on our season 1 shenanigans, head over to newscientist.com/deadplanets. For now, we've got a lot of great stuff coming up for you. Look forward to new episodes every other Tuesday right here in the New Scientist feed. This season, we'll be finally wrecking Mars,
Yes.
pulling more black hole shenanigans,
Oh, yes.
messing with moons, and lots more.
And I just want to say it was so much fun last season hearing from so many of you with ideas for how to destroy the universe. In fact, we have to give a shout out to Sarah, who wrote in last year to ask how we might take down a black hole. Sarah, we found out for you. If anyone else has a cosmic object you want us to figure out how to destroy, just let us know and it could be featured in a later episode of the podcast. Our email is deadplanets@newscientist.com. Bye.
Once again, we're making our enemy more powerful.
Why are all of our space enemies like this?
Because we're picking fights we can't finish.